Good day everybody. For today, I'll be showing you how we can solve a very simple series parallel circuit, or what we call circuit analysis. First and foremost, we should know that there are three types of basic circuit. First is series circuit. It is a type of circuit wherein there is a single path of current that is going through or around the circuit. This one, R1 and R2, they are connected to one another. Next is parallel circuit. It is a type of circuit that there are more than one number of current paths that is going through the circuit. Next is the combination circuit, wherein both series and parallel are integrated to one another to create a single circuit. Before we can solve a basic circuit or other more complex circuits, we should always know the formulas that we are using. First, this one. This is a formula for series circuit. R total, or the R equivalent, is equals to the summation of resistors around the loop of the circuit, which is R1 plus R2 plus R to the nth number resistor. Next is for the parallel circuit, this one. R total is equals to the inverse of this 1 over R1 plus 1 over R2 plus 1 over R to the nth number resistor, which is also equals to this one, product over the sum. But this formula right here is only applicable for a circuit that is composed of only two resistors. So how this formula was derived? Suppose that we have this type of circuit. This is the R1 and this is the R2. How we can derive the formula right there? So it will be just like this. So R total is equals to 1 over R1 plus 1 over R2 to the negative 1, which is also equals to, when we cross multiply this is R2 plus R1 all divided by R2. We cross multiply and multiply R2 to the denominator, so that we can have R1 R2, okay, and this is inverse. Therefore the formula is R1 times R2 is equals to R1 plus R2. There you have it. We will solve this basic example. So the first thing to do to solve for the total current and the voltage across the 5 ohm resistor, first is to simplify the circuit, redraw, and the first thing that we are about to do is to get the total resistance of the circuit. So how we can do that? The rule of thumb for solving this problem is we should always start from the farthest resistor from the voltage source, which is the farthest resistor is this one. So first of all, we need to simplify. If we look at the 6 ohm and the 5 ohm resistor, they are connected in series to one another. Therefore, we can add these two resistances to have a single valued resistor. which is 11 ohms. This is the first redraw that we made. So we need to redraw the circuit for the sake of simplicity and more understanding. So this would be our first redraw. As you can see, there are three resistors that are in parallel to one another. So first, from the farthest resistor, we will start at the 11 ohm. I denote the ohm value as R for the sake of simplicity. So we need to, for the value of this resistance at this section, what we can do is the product over the sum. We can do that by simply multiplying ten ohms multiplied by 11 ohms, all divided by the sum. 10 plus 11 is 21. The answer is 5.24 ohms. So we can replace this section by a resistor that has a value of 5.24 ohms. So let's proceed to our next redraw. So if this is 5.24 ohms, we can just edit this diagram out. So what we can do, so this would be our second redraw. We replaced the two resistor section with 5.24 ohms. So next thing is we simplify again the circuit. We redraw, but it is very obvious that this section is again a parallel section, and this again is a parallel section, which is actually in a single path. If and only if we replace this section by a single resistor like this one, and this section by a single resistor, this one, as you can see, there will be only a single path of electrical current. Therefore, product over the sum again, 10 times 5.24 divided by 5 plus 10, 5.24 plus 10 is equals to 15.24, which is equal to 3.44. The screen is sort of small. So let's proceed. We can redraw that again, and again we sorted things out. So the section right there had become this one. It became 3.44 ohms, and again same procedure apply to this section, that is product over the sum, that is 2 times 3. 2 times 3 is 6, divided by 3 plus 2 is 5, that is 6 over 5 ohms. Okay, so we replace again the section by 6 over 5 ohms. Which is also equals to 1.2 ohms. So to finalize, let's add all the resistances within this loop. So So that is 8 plus 3.44 plus 1.2. That is equals to 12.64 ohms. 12.64 ohms. Therefore, the I total using Ohm's law, IT is equals to Ohm's law. I is equals to V over R, which is 36 divided by 12.64, which is again equals to 2.85 amps. 2.85 amps. That is the answer for the first question, which is the IT. Next is to find the value of the voltage across the 5 ohm resistor. So how we can do that? It's just the same process but in the reverse manner. So how we can do that? We knew that the total current that is flowing through the circuit is 2.85 ohms. So to do that, we will to solve for the voltage across the 5 ohms, we will solve it in a reverse manner. So we all knew that the total current is 2.85 amps as we solved it earlier. So first thing to do is to get the voltage drop across this resistor. This one, we can get the voltage at this node. We name it as node A, okay, which is the same with this node. To solve for the voltage at node A, that would become 36 minus IT times the resistor 8 ohms. So let's rewrite it in a clean word. That is 36 volts minus IT, that is 2.85 amps, multiplied by the resistor 8 ohms. The answer is 13.2 volts at the node A. 13.2 volts. Okay, therefore we can say at node A the voltage is 13.2 volts, and so we can solve for the voltage across the 5 ohm resistor. By what principle? As you can see, these two resistors 10 ohms are connected in parallel, and in parallel connection the voltage at this specific node will remain the same because there is no resistance at that particular node. So if this is 13.2, right there the voltage up until this point is 13.2. okay, so to solve that we will use CDR, or the current divider rule, simply because we knew that the current passing through the circuit is 2.85 amps. Right there, that is 2.85 up to this point. This What I mean is this section, that is 2.85 amps the total. So we can use the formula for CDR. If we use that, we can identify the current that is passing through this 6 ohm and 5 ohm resistor, and the current right there is just the same for these two resistors, and we can apply some Ohm's law to solve for the voltage across the 5 ohm resistor. So let's start. CDR that is I is equals to IT over the opposite branch over the sum of the resistances. That is what I mean right there is opposite resistance of that branch to the sum of the resistances. So how we can apply that? It's very simple. We are looking at the resistance at the current at this branch, and the opposite branch would be this one. These two resistors are in parallel, so we can apply the product over the sum to make it a single valued resistor. So that is 10 over 10. What I mean is 10 times 10 over 10 plus 10. So that is 100 over 20. That is equals to 5. That would be equals to 5. Okay? Therefore, the opposite, what I mean is the opposite. So opposite is equals to 5 ohms over the sum, that is 5 ohms plus 11 ohms, multiplied by the current entering the junction, that is 2.85 amps. Therefore, as you can see, ohms, and ohms, that cancels out. You will be left with the value of amps, which is current, that is 2.85 times 5 over 5 plus 11. Okay, so that is 0.89 amps. 89 amps. Okay, so we knew that the current passing through this two resistors right there, which is 0.89 amps, and by the virtue of Ohm's law, we can calculate for the voltage, which is I times R. Therefore, V at 5R is equals to current of 0.89 multiplied by 5 ohms, which is equals to, that is 4.45 volts. 4.45 volts, because the question is asking for the voltage across the 5 ohm resistor. So what this means is, if you put a voltmeter across the 5 ohm resistor, you should be able to read this voltage, 4.45 volts. There you have it. Therefore, the answer would be I total is equals to 2.85 amps, and the voltage across the 5 ohm resistor, which I labeled 5R, which is 4.45 volts. There you have it. That is the final answer.
Rufus boy, let me love boy, what you know. Rufus boy, let me love boy, what you know. Rufus boy, let me love boy, what you know. Rufus boy, let me love boy, what you know. Rufus boy, let me love boy, what you know. Rufus boy, let me love boy, what you know. Rufus boy, let me